Okay, welcome everybody. It's exactly 2 o'clock, so let's kick off with the next edition of FSR Talks. In the next 45 minutes, we'll be discussing the book you see there, and it's a nice picture. And we have both editors, authors of the book with us. You have above me Anna Creti and below me Fulvio Fontini. And I'm really happy that both of them are here. I don't know how many of you, so a lot of you subscribed to this event, and I don't know how many of you already read the book or how many of you want to get a teaser of the book and then go out to buy it. I'm already in the first category, so I've been reading the book. That also means that I have a lot of questions. But as you know, we always like to be interactive with our audience. So if you have additional questions, don't hesitate to use the chat box you see there, the Q&A box. Just type in there, and if it's a question on the topic we're discussing at the moment, I'll pick it up there. If not, I will write it down, and if we have time at the end, I'll pick it up at that point. Let me just, as a short introduction, tell you a bit about this book. So you should know that it has in total 27 chapters. These chapters are grouped in 8 parts, and we have 335 pages. So I did a quick calculation. That means that the average chapter has 12 pages. That also means that this is really a book that is broad in scope, and I really appreciate it. So anybody working on the economics of electricity markets needs this book, basically. You might not read each chapter at the same time, but it's really what you would call a reference book. Also a perfect book for people like me that teach this topic, because you could say that it's organized in kind of teaching, learning nuggets. Because you have these 27 chapters that are relatively concise. So that also means that as a reader or a teacher, you can still make it your own. A la carte, you can pick up a few chapters and teach about those and also add your own stories to it. So I'm also curious to hear some of the stories of Anna and Fulvio that they use when they teach these topics. What else to tell you? Well, I already said you'll get a teaser, so it's a bit of an Italian aperitivo. It's only 2 o'clock, but I guess for once it's okay, and we'll start the aperitivo at 2 o'clock. So, let's kick off. The first question, and this one I also announced to Anna and Fulvio, so they had time to prepare. I asked them, if you browse through your book, what is the single picture or the single example from a chapter that you would like to share? Because when you teach this course, this topic, it's maybe also one of your favorite topics you teach. I think Fulvio will go first on this one. So Fulvio, which part or chapter is your favorite?
Okay, so first let me say hello to everybody, to all participants. I do hope that most of the participants haven't read the book yet and haven't bought it yet, because in this way they will go and buy it after this presentation, obviously. Um, uh, Coming to your question, of course I like all the book. This is really a joint effort, but there are several parts that I like. Let me put you on the screen a slide which looks rather complex if you see it at the first glance. This is in chapter 9. I think that that chapter in general and that part is one of my favorites, because it, it explains well the specificities of economics of electricity compared to other markets. So one can ask himself or herself why, um, what's the point of focusing on electricity rather than other commodities, and we will discuss about this later on. But I think that this picture sufficiently explains why it is worthwhile focusing on electricity and what are the specificities of electricity compared to other topics. I will briefly introduce it. I don't want to make a lecture out of this slide. Also, not to prevent readers from the pleasure to studying themselves and enjoying it themselves. But I think that this picture encompasses a lot of things that are in electricity markets. On the top right of the picture, you see a schematic representation of what is called the low duration curve. the fact that load, electricity consumption, changes on time with a kind of a systematic pattern over the day, over the weeks, over the year, and you can represent the inverse of the cumulative distribution of the energy consumed in a given period, for instance, in a year. And this explains why electricity is so peculiar, because if load was constant over time, it was perfectly forecastable, we probably wouldn't have written this book. In economics, you would take there would be a simple answer to the question of how should you serve this load? Well, with the minimum cost possible. And this minimum cost is you look at different technologies, pick up the best one. Here, what this graph shows, down right hand side of the picture, shows that there is no best technology, because the different technologies and the different costs basically refer to which kind of electricity you are serving, and electricity are electrons, so the good is the same good always. But the point is that serving electricity always for all hours, or serving just the peak load at some times that emerges periodically, is not the same type of service that you provide. And this links the long run analysis that you see on the screening curves. These are the ones that you see on the down right hand side of the picture, to the hourly supply curve that are depicted on the top left of the picture, which are the ones that represent the supply and demand kind of curves that you are typically used in economics, and that in this case in electricity you see in hourly markets, what we call day-ahead markets. So the picture effectively puts the three together and links them together. The book explains the analytics of these, why they are linked together, and what are the consequences. But I think that thinking at these type of problems shows even to economists how they should look at something maybe they haven't normally thought about from a different perspective. This is what I like for economics of electricity, basically.
Thank you, Fulvio. Very clear. I have to say that 9 is also my lucky number, so I cannot agree more. That 9 should be one of your favorite chapters. Anna, which is yours?
Well, I have the picture that follows that explains which are my preferences. First, I wish to thank everybody for being with us from all over the world, I see, and saving CO2. This is wonderful to make this kind of international webinars being in Paris. So what you see here is something that is there are plenty of arrows, and it is really related to the history of my approach to electricity markets. I have a background in industrial economics, and when I started working on, in general, energy markets and electricity in particular, I have myself discovered a world where this commodity is specific, and because it is mainly physics. And on the left side, you see what we teach when we have to display what we call a meshed network. That is a network where you have more than two nodes. The nodes represent production or consumption, so there can be even injection in the node, in the network, but also consumption, which means that you are using electricity. And this is what we are used to describe as the Kirchhoff law, which is a physics law. And then you have to combine physics with economics. And this, I think, that is the major challenge that has been also very important at the time where electricity markets have been created. So in Europe, this was basically in the 90s after the first directive opening to competition the electricity market. And as you can barely see, but you go on chapter 15 and everything will become crystal clear. You have some, beside the arrows, you have some equations that explain that electrons goes on the least resistance path, something that, I mean, is worth understanding when you teach about economics or when you want to understand how to set an optimal network and which are the consequences of atoms going around how they want in particular. On the other side, it's something that is linked. I have studied a lot the Italian case. So needless to say, we are all Italians, Fulvio and I. The accent also is evident. And one of the fields that we have studied, I think, extensively is the understanding of organization of the market. Some of them, among which the Italian one, are organized with nodal prices and zonal prices. And what we see on with these nodes and arrows on the right side of the slide is a simple representation of the Italian market. I could have put a map, but it is similar for me, and it shows the case where there is no congestion, which is the first part on the right side, and the price is unique. When we have two zones and then two prices, and when we have three prices. And this is something that happens regularly in the Italian market.
Thank you, Anna. I had to unmute myself. So, thank you. That was a good opener. So everybody already gets a flavor of at least 2 chapters, 3 chapters in the book. As you've been teaching this for a while, you also get a good feeling of what is difficult. So you already shared with us what you like to teach, but what are some of the difficult elements in your experience? Where do students struggle, or new people trying to understand the electricity markets?
So I will continue on giving some. I would have liked maybe an interview from a student. This year we have made a joint lecture with Fulvio in space to hear the students in Paris. And it's a course in which I teach electricity and gas. And I can feel how electricity is difficult because when I shift to teaching gas, students say, but it's much simpler with gas than with electricity. And I say, well, that is why we start from electricity. So you have the keys to understand energy markets in general. And I think that the most surprising concept for them is that they, even though they are in masters where they study energy, carbon pricing, so they are already specialized, they do not understand that behind the simple task of switching on and off the lights, there is something very complex behind. So we have distribution networks, so transportation networks, production, the heterogeneity of electricity production with different technologies. And they discover that the changes through which the electricity sector has gone in the last 20 years is very important and very drastic. And the other thing that, I mean, beside this general message, is that when you start understanding and explaining what it is, and then you come to the analytics, they feel lost. In particular because, as you will see in the book, one of the major tools in studying electricity markets is to do, of course, constraint optimization, and in particular using slackness conditions, something that we neglect in economics. And maybe I will let Fulvio explaining why we have this focus on slackness conditions and what distinguishes electricity from other commodities.
Thanks, Anna. Yes, I agree. I think that's the most difficult part, and it is also the part that, from my point of view, makes the analysis more fun, or to some extent justifies the focus on electricity rather than other commodities. In microeconomics, we typically tend to forget about corner solutions. We tend to assume that everything is smooth, interior solution works, cost functions are smooth, twice differentiable. The point, and so when we teach constraint optimization, which is the workhorse of all microeconomists, we typically tend to forget about what happens at corner solution, what happens when the constraints are binding. Almost all of electricity refers to what's the meaning of those constraints, and why are they so relevant, and what it matters when they are binding, when one is binding, another one is binding, because this all explains when capacity is fully used or is not fully used. These all have to do both with transmission when you introduce transmission network, but also about optimal dispatch when you don't, as was the case of a picture I showed before, when transmission networks are not even yet introduced. This all explains which marginal cost is the relevant one, the last one used, the first one not used. And so this is typically the difficult part, because normally students are not too used to pay attention to what the meaning of the constraint is, which incidentally I think that explains why everybody should take a course on economics of electricity, even if they're not interested to the topic itself, because it helps even for standard industrial organization students, because it really helps to focus on things that are relevant. Unit measures, for instance, which are things that generally you tend to forget, but in electricity, if you don't pay attention to the different unit measures, you mix up things, and you cannot mix up power and energy, for instance, because they are two different things. They are related, but you need to know what they are. Time dimensions, for instance, short run, long run, medium run, what they mean effectively. So these are all things that you see in practice in electricity, but typically students are not very familiar with, so they tend to struggle a bit about that.
Okay. I think I also wanted us to sort of try to summarize the rationale of the book, because you write very nicely in the introduction. You position yourself as a book that comes after industrial organization, so you already understand some of the economics, but then you need to get a grasp of what is specific to electricity. And in your opening comments, you already referred to a few of them. You already said there is no best technology, which is not typically the case in other sectors. Then Anna started talking about pricing the network. And you now also, conceptually refer to that as these slackness conditions, which basically I think means you add a price to a constraint, right? So by doing this constraint analysis, you know the price of your network, basically. So what else is particular about electricity? Have you mentioned already all the issues, or have we still not mentioned one that makes electricity special and more complex than gas? And Anna is allowed to say that because she's a real gas expert. So if I would say that as more an electricity expert, that, I would be moving on thin ice. So,
yes, I think
Anna,
that
like
another point that we try to make clear in the book is also the way in which electricity has to respond to a CO2 regulation. And I mean, we all know about the decarbonization needs of the electricity sector, but it is not simply changing the technologies. So on one side, we discuss a lot the transformation of the electricity industry due to the increasing introduction of renewables. But on the other side, we also explain the way in which the electricity price is affected by the introduction of a CO2 price. So I think that is an interesting issue to understand how the specificity of the electricity market combine with the specificity of CO2 regulation, which is again something that we cannot study in the same way for other markets, both because, I mean, as we know, electricity, if we think of the European system of emission trading, is the major factor that is, I mean, under this kind of regulation, and also because this idea of the heterogeneity of technologies transmits somehow to the electricity prices in a very specific way that we cannot compare to what happens, I don't know, in the paper industry or the aluminum industry.
I would add, of course, I agree with Anna. In general, I tend to agree with Anna.
In general.
And in the specific for the book as well. I think that what makes economics of electricity as a topic and as a book, I don't know whether it is easy or not, but definitely fun, is that this is a topic that is at the intersection of several aspects. There is a regulatory aspect, Anna was mentioning, there is the economic aspect, of course, there is a physical aspect of the matter, and these interact. You need to take into account them together. One of the things, for instance, that typically students don't expect to at the beginning, and that is also explained in the book, has to do, and I think that also Leonardo was having this in mind, has to do with the balancing issue and the physics of the electron, the fact that the electron, as Anna was saying at the beginning, goes where it finds the least resistance. It doesn't go where the economic exchange has gone. And you need to couple the two, the economic relations with the physical relation. And this balancing is it's a natural thing when you think about it, but if you have not been exposed at the beginning, maybe you find it a bit awkward. I always start when I teach this topic with the trick of turning off the light if the light of the room is on, or turning it on if the light of the room is off, and asking what has happened. And the question is not trivial. What has happened means what happens behind that plug. What is the physical and economic nature of the good that at the end of the story is lighting your bulb or is charging your device or whatever service you are using this electricity for. These aspects are not they are complex, but you can take them into account, and you need to know them. So at the beginning of the book, for instance, there is an explanation of an introduction, an introductory explanation of the physics of electricity, whose purpose is exactly this, to help those who are not familiar with, to realize that these constraints are the essence of the good we are discussing, are not side other topics.
Okay, great. Let's now dive into some more specific issues. And I have a few on my list, and I see some participants already putting specific issues in the chat box. So let's pick them up by going through the chapters. So let's first go to the discussion of how dispatching works, because that is in chapter 10 when you talk about market solution to optimal dispatch, or which power plant runs when. And then you refer to that phenomenon of negative prices. And can you just explain us how is it possible that we can have negative electricity prices?
I will take this question. This is one of my favorite anecdotes that I teach first year microeconomics, and I also teach energy economics and economics of electricity. So I always tease a bit the students with the fact that when in first year micro you solve demand and supply, and you find that there is a negative price, you must have gone wrong somewhere with the sign. Because we always teach that price are positive and quantity is positive, so if you see some different sign, there is a mistake in it. In economics, it's not a mistake, it's something that can happen. And they sometimes also quite natural. Briefly, why does it happen? Technically, these are because of non-convexities of costs. Basically, what is a negative price? It means that someone pays to produce. How is it possible someone might be willing to pay to produce electricity? Because if from the production of that production of electricity you gain more than what you pay, you are willing to do so. And you can gain more for several reasons. You can gain more, for instance, because you receive subsidies as long as you produce. This is the case, for instance, of some renewables. You can gain more because you are losing at that point in time, but you expect to gain more later on. For instance, this is the case when production is timely linked on a long time scale. So that in order to be able to produce in the next hour, you need to be hot and present and have already been producing in the first hours. So these are sort of things that can happen, and effectively in some markets you see it. Even in those markets when you don't see negative prices, that doesn't mean that the economic effect is not present. It's just that there is a price floor that is covering this effect, which means that there is a cross subsidies, and some are subsidizing some others. And incidentally, this story of cross subsidies happens frequently in electricity markets, also for different type of services, transmission services, production, and it's another thing that you can learn studying these. And basically, economics is about efficiency. Efficiency means giving the right value to the good. But here, the good is not just the electron. To get that electron that hits your bulb, you need to have several goods together. And this is what you have to learn when you study this topic.
Thank you, Fulvio. So let's jump to chapter 11. Chapter 11 is about balancing markets, and we already have a comment in the chat box on balancing markets. But before we pick up that comment, let me ask you, so you explain in the chapter this double settlement thing. Can you just introduce us a bit more to, you already said switching off the light and what happens behind there, but can you explain it a bit more?
Oh, yeah, this is a challenging question, by the way. So double settlement is a specific form of settlement. You need first to explain what settlement is. As we said, electricity needs to be balanced in real time at every point in time, because electricity, the electron goes on the grid almost at the speed of the light. So whenever there is an extra demand or supply, an extra consumption, at that very point in time, the equivalent amount of injection or withdrawal needs to be introduced or withdrawn from the grid in order to maintain withdrawal and injection balance. This is what balance is. Now, what happens? Of course, economic exchanges take some time. So it is rather hard to relate the exchange, and for the physics of electricity, sometimes it's impossible to relate the exchange to the effective flow of the electron. So exchanges takes place before. This is the reason why wholesale markets are called day-ahead market, because typically in most of the markets they occur before the effective delivery. Effectively, these are futures, even though very short futures with a very short time horizon. The point is that Futures are futures, so they are just promises to inject or promises to withdraw. And you need to have a system that provides the right incentive for those promises to be linked with the effective withdrawal or injection. Or to put it in a different way, you need to have a system that forces the one who has made the promise to commit to the process. Now, so what is an imbalance? Suppose that you promise to produce, the power plant promises to produce, and and in real time, then it is producing less. Some other plants need to replace that lack of production to maintain the withdrawal, or some loads need to be cut to balance that lack of injection. This is costly. And most of the time, in real time, is even more costly than the production schedule before, because producing with a quick time horizon implies more cost. Not all technologies can do it. There is a need to be to maintain the power plants hot, so it can be even more costly. So the double settlement is the system which has been implemented in this simple example, for instance, to make sure that there is no wrong incentive for the one who scheduled the production the day ahead to overschedule it, regardless of what is the effective production real time. The one who would do that, the negative imbalance, would have to pay for the calling of the supplementary production that replaces, or the lack of the load that replaces its imbalance. And this call occurs at a price which needs not to be smaller than the price that the producer the day ahead received when it was scheduled. Need not to be smaller, can be higher. This is the double settlement in a nutshell. Of course, you can make it more realistic with lack of load and all possible cases, but in a nutshell is this. Is a system to take into account both what was promised and what has been effectively delivered in a cost-effective way.
Thank you, Fulvio. So Anna, can you say a word more about, you already interacted with Pierre in the chat box, so on the differences between gas and electricity balancing?
Well, to keep perhaps the discussion short, I would say that there are two main differences. One is the time constraint, and the other is the market design. Electricity, even wholesale gas markets are at the daily horizon. Electricity markets are hourly markets or real-time markets. So, as you can understand, the need of the balancing becomes immediately different depending on the horizon of the adjustment. The second point is that, given that, and this is also going through what Kelvin is asking, given that still those markets function and have been designed without including storage for renewables, but still renewables exist. The difference between what happens in the day ahead and what happens in the intraday markets is huge. So the demand for balancing is much higher in electricity markets than in gas markets, where, by the way, the wholesale market is the extension of the previously organized balancing arrangements between the national operator and the grid, because gas demand varies essentially because of differences in temperatures, and what cannot be arranged by storage goes in the balancing market. And the nomination system, to which Jean-Pierre is referring, also depends on the usage of infrastructures, which is now, I think something different from the electricity, where we struggle to have efficient markets first.
Okay, thank you. Next topic, now we jump in the book, because you see in the subtitle it's not only about markets, it's also about competition and rules. So about competition in chapter 13, you refer to 24 antitrust cases. So which ones do you maybe talk about a bit more in your classes that deserve to be remembered?
Yes. Yes, I start from, it's also a trick for teachers. We in this book, we make, we hope at least, to make balance between theory and practice. And by the way, there are some what we call boxes in which we do this link between what we describe with analytics and what happens in reality. And in one of these reality checks is to understand what does it mean abuse of market power in electricity markets. And when I teach this topic, which I like a lot, because I mean, as I was saying, as an industrial economist, I really like understanding which are the roots of market power. I showed students, I connect to the website of the DG competition, where you can do the search for the major competition cases that have been decided at the commission level, which means that the extent of the case involves a very high threshold of potential damage to consumers. And I make the comparison between other sectors, groceries, beers, pharmaceutical, and what happens in the energy market, so both in electricity and in gas again. And we go through the cases and we see the names of the firms involved in this abuse of market power or other kind of unfair behavior in terms of competition. And I have to say that there is an interesting evolution in these cases, because from the 2002, 2003, which I think it's the beginning of the existence of electricity markets, up to 2008, 2009, we have the in Italian would say I soliti ignoti, that is the ex-monopolists. So all the monopolists, all the incumbents have gone through the lenses of the Competition Commission for one reason or another, witnessing the difficulty in this market to shift from the ancient monopolies to a new paradigm of competition. There are some practices that are about contracting, other practices in which there are abuse of dominant position in the wholesale market. But my impression is that the dynamics of competition has really started when renewables are coming to play into the picture. So starting from 2010, there are less cases in the wholesale market and more cases in the retail market.
Okay, very interesting. Let's also pick up on the question of Thomas, which actually connects to chapter 24, because Thomas asks, it's a bit up in the chat box, on how the wholesale market will evolve with renewable energy. And related to that, I also had the question, you often hear we have a zero marginal cost system. What will that then mean? How will pricing work in wholesale markets? And I think it would be nice if you could both say something about that.
Yes, this is a challenging topic, and I think that even though many papers have been written, there are some still some interesting aspects to study. And just also to say something more, I think that one nice added value of the book is that we have summarized a lot of papers in the same frame, in the same context, in the same model. So to really understand the evolution of the market by adding for every chapter a specific topic. And when it comes to understanding the relationship between renewables and, for instance, prices in the wholesale market, we discuss, of course, the merit order effect. That is the fact that having zero marginal cost resources is going to depress, in theory, the wholesale price, but it is not always the case. One of the examples is, again, the Italian market, where because of congestions, we may somehow create also pressure on the existing fossil fuel generation, such that the price increases in some hours or in some zones. And more generally, I do not think that due to renewables, the role of the market is zero. In the sense that those markets are there also to create transparency, to have a formal place where demand and supply can meet. And I do not believe that the future of the electricity market is the same as the telecommunication market. That is what we have, like in our mobile phones, where we pay for capacity and zero for usage. This is impossible because even renewables, yes, of course, they do produce thanks to the sun or wind, which are renewable resources, but still they have an important OPEX and CAPEX. And even though I strongly believe in the decarbonization of the electricity industry, even if we have power to gas or other technologies that are to backup or storage, as it was also in one of the questions, there is some investment to be covered. And markets are the right way to give incentives, perhaps with some adjustments in the market design.
Okay.
Maybe I could add, of course, I agree with Anna. Maybe I could add that I think one of the, if I, in my humble opinion, one of the good point of the book is that we discuss two things related to this question. One is that we tend to describe, and this also explains why it is called economics of electricity, not economics of electricity markets, because electricity is a system. There is an electricity system that is rather complex. And it is discussed from the economic point of view, all points of the system, discussing where in those points there are market or organized market settings, and of which kind, and in which parts there are other type of arrangements which still can be analyzed from an economic point of view, even if they not necessarily imply a centralized organized market like a pool, for instance. So this is a point that also when I teach I tend to stress quite a lot. I insist that there is no electricity market. There are electricity markets because electricity is a vector of components. And when, in order to take advantage of the electron, as I was saying, there are a lot of components that needs to be taken into account. In some systems, it is the case that perhaps in the future, the role of the wholesale market will be diminished. That basically gives the value to the conversion of the primary energy of gas or kinetic energy of wind or into the electricity vector, the energy vector that is used. But that's just one part of the electricity system. So in all those markets, for instance, where we see that the wholesale price perhaps is reduced, and Anna was right in saying that maybe in those markets we even see that is less reduced than it should be, when you take into account the introduction of renewable, and perhaps it's becoming more volatile. But even net of all these, even if we were to see a reduction in the wholesale price, we would see that some other cost components might be enhanced, investments we were discussing, or balancing we were discussing. So I think that one of the good things of the book is that it just not takes into account that in the world a lot of possible different settings, economic settings exist for exchanging electricity, but also that it discusses all those components and the relationship between those components.
Thank you, Fulvio. Thank you, Anna. I think we did exactly what we promised in condensed interactive 45 minutes. Aperitivo is over, but you have the book there. You have all the links available. So go out and, buy yourself a Christmas present, I would say.
Not exactly, but maybe.
Buy yourself also a Christmas present, maybe.
Thank you all for your very active participation. Bye-bye.
Thank you very much. Bye-bye.
Ciao, ciao.